Hey guys, for this video, so I just want to talk about more things like the complex number. So student always having tough time to deal with the complex number with the real number. So we'll do a few examples regarding some of the problem that we have done in class. Okay, especially for addition, subtractions, multiplication, and division for the complex number. Okay, so first thing I would like to talk about is that the complex structure. So it's always given as a plus bi, so a, which is the real number, and then bi, which is considered the imaginary portion of the complex number. Okay? And also the I is considered square root of -1. So if we deal with I squared, so that's just like negative square root of -1 times square root of -1, which is -1. Or we can just rewrite it as square root of -1 quantity squared. So that's why the radical and the exponent got canceled. And then I to the power of 3, so that's just like I squared times I. So I squared is -1 times I, so then that'll be -I. And then I to the power of 4, it's just like I squared times I squared. So it's -1 times -1, which is positive 1. And then I to the power of 5, it's I to the power of 4 times I. Again, what I did here, I just used the properties of exponent to split those power. And then it's 1 times I, which is I. So every 5I right there, so you go back to the cycles, back to the original I. So this one's called the cycles of I. So now let's do some basic practice. So for the first one, we do have quantity of 1/2 minus 1/3 I. And then plus 1/2 plus 1/3 I. So first thing that you want to do, you want to regroup the number, the real number. Okay, it's addition, so you want to combine them. And then -1/3 I, just group them with that 1/3 I. So you may notice that 1/2 plus 1/2, which is 1. And this one turns out to be 0, so eventually it's going to be 1. Or you can rewrite it as 1 plus 0I, either way. Okay? And then for number 2, so we got 5 minus 3i times the quantity of 1 plus I. So anytime they see the binomial with the binomial, guess what you have to do? You want to FOIL. So 5 times 5, 5, 5 times I, 5i, and then -3i times 1, -3i. -3i times I, so it's -3i squared. So combine the like terms. So 5i minus 3i, so we do have 2i. I squared, we may notice that is what? -1, so -3 times -1, so it's positive 3. So 5 plus 3, so it's 8, 8 plus 2i. And that's what we got. Well, looks like that would be a typo right there. That one's supposed to be 8 plus 2i, not 2 plus 2i. Okay, so I probably did something wrong for the previous PowerPoint. And now, so for number 3, so take a look at that number 3. So number 3, that's division. Now the thing is that for the rational expression, there's no such thing for division. So anytime they see division, that means you want to turn it to multiplication. So the way to do it is by multiplying the conjugate. So the name for the technique is called rationalizing. So 5 minus I over 3 plus 4i. So anytime that you try to rationalize it, that means we always multiply the conjugate of the denominator. So the conjugate of the denominator, which is 3 minus 4i. And the purpose of multiplying the conjugate, so we can apply the difference of 2 squares for the bottom part. So we got 9, that's 3 times 3. So 4i times -4i, -16i squared. So that just takes care of the denominator. What about the numerator? Again, it's all about FOIL. So first, outside, inside, and then last. So 5 times 3, 15. 5 times -4i, -20i. -I times 3, -3i. -I times -4i, which is positive 4i squared. And then simplify it, so 9 plus 16, 25. And then the top part right there, again, this one turns out to be negative. So 15 minus 4, 11. And then combine the like term, -23i. And nothing we can reduce. Guess what? We just leave it. Okay, so if you guys do like the video, so please subscribe to the channel. Thank you.